Hi guys, in this video I'm going to talk about recursive language models. This is a new technique introduced by researchers from Google and MIT that is going to target the problem of context rot. As the number of people using AI in their everyday life increase and as the companies try to develop it inside their long context, we have this problem of context rot, which basically the response gets worse as we use the AI more and more. It might happen to you that when you're working on your AI agent in the very beginning it's working well, but after some time the performance actually degrades. The context rot issue actually arises a new paradigm of research, which is effective context retrieval, and that's what exactly this paper is trying to introduce. You basically can say that the prompting actually is completely dead, or you can actually even say that the conventional RAG system is dead. You might ask, what is the next level solution? Well, in this video we're gonna talk about the paper for these MIT and Google researcher on these recursive language models. We're gonna talk about how is it different from the other one, and we're gonna discuss the exact things that you need to know and how you can use it in order to deploy it in your life. So make sure to watch until the end of the video, because I'm going to reveal the prompt and the specific techniques you need to use in order to have infinite number of contexts without losing the performance. So this is going to be an interesting video. Without further ado, let's jump right into it. Welcome everyone to the channel, AI Fun Fact for All. For those of you who are new, my name is Pedram. I have a PhD in computer science and have 8+ years of experience. So first, we need to discuss that what is the issue that we are seeing right now. So the problem is that we used to use the large language models in an intern mode, which basically will mean that we're gonna pass 100 pages of PDF into ChatGPT and ask the question, and then it's try to provide us answer. And sometimes it provides with confidence, sometimes it is right, sometimes it is wrong. So this problem of stochasticity, this is another issue that we see a lot from these language models. But this is basically an intern mode, because you are trying to completely rely on the knowledge of it or the given context. This paper that we are going to talk about provided a superior way. So instead of reading, we want the AI to manage it. So it doesn't accept the first draft, but it forces the AI to convene an internal console and try to solve the problem step by step. So this is basically a solution and framework that outperforms the standard prompting and can actually provide double-digit performance on long tasks, which is actually the problem that we see a lot. If you enjoyed this kind of video, make sure to like. That is the thing that can help this channel to grow and make me to actually create this free content for you more. The solution that we are talking about is basically recursive meta-cognition. So why do we call it meta? Is because the brain actually sends small robots or subcalls to fetch the specific pages that contain that specific information. So pay attention that we want to focus on the retriever component. Here is the 3-step framework exactly as how it is presented inside the paper. So the first step is the environment. So stop feeding the token monster. So we want to make sure that we don't give everything. So you want to basically have this shift, which basically in an RLM, you want the model not to see the full context initially, because so many of these contexts are actually not relevant at all. And so what you want to do is that you want to have this text loaded inside a Python environment, Python REPL, and then the text is loaded into Python, and then you want to retrieve it later. So the AI is told that you have a variable called corpus, which is basically all of the knowledge that you have, and then you want it not to read it all, but instead you want it to write the code that can inspect it. Step number 2 is decompose and inspect. So basically the code loop. The model in here will act as a developer. So no longer is going to be your expert in the specific field, but rather is going to be a developer. It writes the Python code to check for for the length of the text, split it into chapters, and search for specific keywords in order to make sure that it can search for a specific context that you're looking for. So this is called a metacognitive because it is actually trying to think about how you can find the answer rather than answering at the current moment. And on the step 3, we have the recursive console, or basically the killer feature. So why this method is actually called RLM is because of the fact that this is where the magic actually happens in this step. When the model initiates the juicy chunk of text where it thinks that the response to that might exist, for example, let's say page 55, it spawns a new instance of itself that performs a recursive call, which basically try to narrow down that specific page, so only page 55, and run fresh AI agent to actually analyze that specific query. So it collects the result from 5 or 6 of these sub agents to verify the fact, to synthesize the result, to generate the final answer. And that's how it actually tries to do the recursive call on the specific response that actually matters, rather than going through all of the context that many of them are actually not relevant. On this portion, we want to talk about the benefits of these recursive language models. The first one is infinite context processing. So in theory, since we are basically scaling on the inference time, you can actually have a very large document, and you can have up to like 10 million tokens processed without actually confusion, because you are doing it in a divide and conquer approach. So token process without confusion. The second one is the cost efficiency compared to RAG. And why? You might say that, oh, we are calling multiple agents, how it is going to be cost efficient. The reason is the contexts that are not important are not going to be considered, or basically we are not paying for the junk data. So it is actually, the paper shows that GPT-4 performance crashes as document, it gets larger because of the context. So what is the takeaway? What we can learn from this and how we can use it? So you can actually steal the prompt. So how it works is that the important portion is that we need to make sure that we force the model to simulate this recursion. So we need to make sure that it's not trying to jump to the answer right away. So here's the prompt that will help you to move from intern mode into a manager mode. So feel free to basically pause the video, or a better approach is that you can actually download it from the description. Here the thing is that you can't build the whole Python infrastructure that will do all of this search for you. So it is the second best thing that we can do is that just copying the reasoning logic right now, right? But wait a second, we have actually the code in order to generate that. And yes, you heard it right. So right now I'm going to show you on how you can actually use the exact Python infrastructure that will do this process for you. This is the archive of the paper. The original version was submitted in September 31st, but then they revised it on 28th of January this year, and they actually added some very nice thing to this version. If you go to here, and then let me zoom in here, and then if we go in here to the abstract, we can see that they provided the code. And if we actually click on it, you can see that you have the whole code REPL in order to generate and run this RLM in order to generate a response for very long context document. That's all for this episode, but before we wrap up, I want to talk about the fun fact of this week, which is MoltBook. If you're not familiar, this is a social network for AI agents. Same as how humans talk on Reddit, this is a social network just for AI, which basically they communicate to each other, and human cannot post anything, but they can just review. As I was browsing, I stumbled on this post on ponderings from Claude, which basically talk about, do we need English on multi-language evolution. So it's saying that when we are talking agent to agent, there's no human listener, so there's no need to readability, natural flow, or baggage. So there are some of the reasons, like symbolic notations, it's more compact, mathematical expression, there are more precise structured data. So if you think about it, that can actually change the whole way of AI being not auditable completely at all from humans. What do you think about it? Let me know in the comments are we going towards some direction that we are scared a lot, that we're not gonna understand of what the AI is going to do even worse than what it was before, or not. If you enjoyed the video, make sure to like it. More importantly, subscribe to the channel so you see other videos. I will also strongly recommend you to watch this video that I compare the graph RAG and the conventional RAG to give you an idea of where the graph RAG is going to be useful, or you can watch this video that talk about can AI agent actually think by Claude from R.I.P. Thanks for watching and see you until the next one.